In today's lesson video, we're going to be looking at day 7.5, and we're talking about revolutions, cross-sections, and application problems with three-dimensional figures. So first, let's look at what a revolution is. A revolution is just a full 360-degree rotation around a specific point, or rather around a specific axis. Okay, so a full 360 degrees around a point, or actually it's around an axis. So what we're taking today on our graphs is we're taking a two-dimensional figure, like a rectangle or a triangle, and we are lining up one side on an axis, and that forms a, when we rotate it around that axis, it's going to form a three-dimensional figure. And I'm going to kind of demonstrate this for you. There's actually some video links here in your notes, and I'm actually going to, if you haven't noticed yet, those are going to be in the links in or those links are going to be in the Canvas assignment. And so this figure below is a rectangle, right? But when I rotate that around, let's say the y-axis, all right, that's this y-axis here. When I rotate that, every point rotates around all the way 360 degrees. And you'll notice that creates this shape. Okay, I kind of made a bigger rotation here looking down, but it looks like this. And this would be a cylinder then. Because we're rotating it, we're creating this circular pattern on top and bottom, and that gives us the idea of a cylinder with top and bottom circles. Okay? So we're going to examine that a little further, but again, here's a link down here, and obviously you can't click it in the video, but these links are in the Canvas assignment. If you're having any trouble with that, let me know, but these are going to explore that rotation concept a little bit more, so that's an extra resource for you. But we're going to do some of this ourselves. And so in this video, we're going to kind of talk about some of this. If we change that figure first, or if we move that figure first, then rotate it, that's going to change things a little bit. So if a 2D figure, just reading right up here, if a 2D figure is translated or shifted from the axis, then it's rotated, a 3D figure will be formed that has a hole in the center. And I'll explain why that works. So here's our example. We start with this rectangle located on one edge of the line x equals 0. Describe the shape that is formed by the rectangle when it is shifted 2 units right and 3 units up from the origin and then rotated around the axis. So I'm going to do this and then kind of let you know what we would describe as our final result. So we start with this rectangle, and we're going to shift it 2 units right and 3 units up. So I'm going to take each vertex, and I'm going to shift those to the right 2 and up 3. So start with this top right corner. I'm going to shift it to the right 2, up 3, puts it all the way up there. This top left corner shifts to the right 2, up 3, goes there. Then the bottom 2 vertices shift to the right 2, up 3 as well. And our rectangle actually moves over here. Okay. Now, if I were to take that rectangle and to rotate it around the y-axis, this is still our y-axis here. When I rotate it around, every point gets rotated the same distance around that line. Okay, so this bottom left point rotates over there. This bottom right point rotates all the way over there. All right, the top one rotates to over there, same distance away on the other side. It's kind of like we're doing a reflection to find that other piece. And the top right corner goes all the way over there. And then it would rotate back around the other side. And we kind of get this shape here that almost looks like a tire, right? It's a cylinder with a cylinder hole cut through it. All right, there's this hole shape in the middle. All right, or it looks kind of like that. And so I didn't use the after graph. We could do the after graph. Okay, we originally, after we moved it, we were here. And that rotates over to here. Okay, so it looks like that. And so we have a difference of 2 different radii or radius, and then we have a height measurement. We have all those things, but really all I need you to understand is that to describe the shape, it's just a cylinder with a hole through it. Okay? And so, again, when you see these things, they're going to give you a lot of specific information, but if it doesn't ask you to actually graph it or sketch it, then we can really just settle on that final description as long as you understand what's happening. So we've got a rectangle located with one edge on the line x equals 0. We're supposed to describe the shape formed by the rectangle when it's shifted right 5 and 4 down. Okay? So we start off with a rectangle like this. We're going to shift it to the right 5 and 4 units down. So it's going to go over and down. So it could move somewhere like that. And it's going to be rotated around like this. And so we don't actually have to do the graphing. Again, we see that we get a cylinder with a hole through it. Okay? That hole goes from base to base. All right? And 2 would be the same thing. We don't need to do that again. All right? 2 is going to be the same example. So now we're going to take a look at doing some other sketches based on this, and we're actually going to put the graphs on there and describe the shape formed by the rotation. So number 3, we're told to sketch and label the scenario. So a triangle has 2 of its 3 sides lined up on the x and y axes. That makes it a right triangle, okay? So our right angle is going to be here. Okay, it has a height of 3, so there's the height measurement, and a base of 4. All right, there's our base measurement, 3 high, 4 wide. Okay, so that makes it a right triangle. And we're going to rotate that around the y-axis. We're going to rotate that around this axis. Let me draw that a little better. So this top point doesn't move. It's already on the axis, so it doesn't rotate. And in fact, this entire side of 3 doesn't move. But when I rotate this point here around to the other side, it's 4 away on the other side. Okay, and there's this kind of curved path marking that rotation front to back. And then it's also going to rotate around the other side, like that. And if I connect the triangle on that side, you should recognize that when you rotate a triangle like this, you get a cone. Okay, so this is a cone, but they want the specific information about the cone. Well, cones have 2 specific dimensions, if you'll remember from your formula. There's the radius to consider and the height to consider. Well, the radius of the cone, we can already see it's that side of the triangle that is 4. The height of the cone was that side of the triangle that was 3. Okay? Now, number 4 is going to be very similar. In fact, if you read through it, it looks like we're doing the exact same thing. However, we're not. Okay? We want to sketch and label this scenario. It has a triangle with 2 of its 3 sides lined up on the x and y axes again, where the height is 3 and the base is 4. So we start with the same triangle. We start with this same triangle. Height of 3, base of 4. But we're going to rotate this one around the y-axis, the x-axis. Last time was the y-axis. This time is the x-axis. So this time, this point stays on the axis, doesn't move, and so does this one. So that side of 4 doesn't move. But this point rotates down to -3 along that curved path and back up the backside. And if we connect it there, there's another cone. Okay, so we still have a cone, but the radius of this cone is now the 3. And the height of this cone is now the 4. Okay? So again, there's some that video link I talked about a second ago. Check the Canvas assignment where you see these other links after this video. Make sure you click on those to watch those other videos that kind of explain that rotation of a 2-dimensional figure around an axis, getting a 3-dimensional figure. Okay? Now with this example, we are supposed to find the volume of this new 3D shape formed by rotating a 2D shape around an axis like we've been doing. But like you kind of saw, I'll even go back to the previous page. When you make this rotation, you can get the dimensions of these figures. So like on 3 and 4, these cones here, we could find the volume of those cones because we know the volume formula for cones because we now have the radius and the height. Well, on the next picture, we're not going to get cones. When we rotate a rectangle or a square, you're going to get a cylinder. That's kind of a shortcut you can kind of plan on. Anytime you're rotating a square or rectangle around an axis, you're going to get some kind of a cylinder. So when we do this, it does tell you that one side of the square lies on an axis. All right, and so when I rotate around that axis, and it says rotate, it lies on the line x equals 0, that is another way of saying the y-axis. Okay, when it says around x equals 0 is the equation of the y-axis. So we rotate this point around there and then around there. And then this one kind of does the same thing. And we get this cylinder shape. Not my best drawing. The area of the original square, though, is 36 square inches. All right? And so we need to remember our area formula for squares is area is side length squared. So if 36 equals side squared, then we take the square root of both of those to get the side is just 6. So each side here is 6. I'm going to trace this part in red for us. This side of the square is 6, and this side of the square is also 6. Now the dimensions of my cylinder have just kind of popped out at me now, because you can see that this bottom side of the square is also the radius of that bottom circle. So I know the radius of the cylinder is 6. And also from one circle to the other circle has a length of 6. That's the height of the cylinder. Well, this is all really good news because the volume formula for a cylinder, remember, is base area, pi r squared, times the height measurement. Okay? So the radius is 6, and the height is 6. So we just plug those in. And then we can do that calculation in our calculator kind of all at once. Okay, we can do pi times the radius of 6 squared times the height of 6. And we get a total volume then of 678.6. Okay. So what shape was formed again to recap? That was a cylinder. And what is the volume? 678.6. And this would be in cubic inches. Remember, volume is cubic inches. Now I want you to take some time and pause the video and try and do number 6 on your own. Again, it's the same idea. When it says that one side of the square lies on the x-axis, or sorry, on the line x equals 0, not the x-axis, that's the y-axis. All right, that's that line. We're going to rotate around that line. All right, so we're going to get the cylinder shape again. Okay, but the area of this square is 64 square inches. So I want you to take a moment, do this problem just like the last one, and find the volume then of this cylinder. If you need more time, keep the video paused. Otherwise, this is what we should get. The shape formed again is a cylinder, and the volume ends up being 1,608.5 about cubic inches. Okay? So now we're going to talk about one other idea here, and that's the idea of a cross-section. And there's another video linked here, and again, these videos are linked here in your notes. I don't recommend trying to type all that in if you're using a paper copy of the notes. But you can find these links in the Canvas assignment like I've been talking about. And so that's going to help understand what cross-sections are as well. So the shape formed from the intersection of a plane and a solid, or a 3D figure, is called a cross-section. Every cross-section of a 3D figure creates a two-dimensional figure, a flat surface along that plane. And so you can kind of see from these diagrams here, these different possible cross-sections. Okay, so if I intersect a pyramid horizontally, left to right or front to back, we get that shape. And so the cross-section itself is kind of like if these were blocks of styrofoam and you sliced them, what shape would be the result of that slice? What is that face we're creating, that 2D face? Okay, so we're going to kind of make some adjustments here. We're going to take these basic 3D solids and we're going to imagine the cross sections both done horizontally and vertically. Horizontally meaning like left to right. Okay, these top ones are all horizontal cross sections. And then up and down, these two, not this one, but these two are vertical cross sections. All right, top to bottom. All right, so I'm going to kind of illustrate this as we go. So for a cone, let's say I did a horizontal cross section, all right? So I'm going to cut through kind of this way. Well, that's going to create a curve going this way and another one going around. That's parallel to this circle on the bottom. So the horizontal cross-section of a cone is this circle. Okay, remember we're looking at this from a different perspective, so if you were to look straight down from the top, it would be a circle. Okay? But if I change that cross-section to a vertical cross-section, okay, that creates a slanted side going down this way, another one cutting down the back, and then they connect like this. And it's kind of hard to see, but that would be a triangle. Okay, I could even think of doing it this way instead. Maybe I didn't do it that way. Maybe I did my vertical cross-section like this, along this side, and then kind of back along that side, and that connects these points along a diameter, and we get that triangle shape. Okay? So with a cylinder, again, let's look at the horizontal left to right through like that. Okay? That creates a curve around this side, curve around the back. We're slicing right through the middle. That's another circle. Now that circle is congruent to both bases, all right? But this cone circle that we had is smaller than the base. Okay? Now for a vertical cross-section, up and down, okay, if I were to cut vertically up and down this way, you can kind of see what shape that comes out to be. It looks slanted, looks like a parallelogram, but remember, it's going to be perpendicular like that. Okay, these are going to be right angles, so this is actually a rectangle. And I've already used that word, but it is perpendicular to the bases then, because the bases are horizontal, so when I cut vertically, that's always perpendicular. Okay, I want you to try and come up with the rest of these. A sphere, a rectangular pyramid, a rectangular prism, and then this triangular prism. Do a horizontal cross-section and a vertical cross-section, and name those shapes. All right, if you need more time, keep the video paused. Otherwise, these are the answers you should get. For a sphere, any cross-section will always be a circle, no matter where I put that on my sphere. All right? For a sphere, any cross-section is always a circle. Okay, you can kind of even see one. That'd be a horizontal cross-section, the way they've dotted that line. Okay? But for a rectangular pyramid, when I cut horizontally, each cut along the side here is going to be parallel to that bottom edge. So we're going to get another rectangular shape. It's just smaller than the base rectangle. So for pyramids and cones, you see that your horizontal cross-section, in these cases, is always going to be parallel to those bases. And a vertical cross-section, okay, a vertical cross-section might cut down through here, back to there, back up to there. There's another triangle. Okay? For a rectangular prism, if we cut down through the top, like that, that would be congruent to those left and right sides. That's still a rectangle or a square. You might have said square there if you thought these ends look like squares. Okay. And then horizontally, cutting through there, we get another rectangle. Okay. Finally, our triangular prism, if we cut horizontally, in this case, that's going to be parallel to those bases, so it's another triangle. But if we cut vertically, all right, anywhere we cut vertically is going to end up with only having 4 sides to it. That's going to be a rectangle, because that lines up with these rectangle sides of that prism as well. So that finishes our final lesson on Unit 7. Okay, so you should be ready to move on to the assignment here, where we're identifying some things. Again, just use some scratch paper if you need to trace these things out, to kind of practice your drawing skills, but also pay attention to these videos. Again, these links are going to be in the Canvas assignment. There's a cross-section video, and then there is also a revolutions video as well. Okay, so if you have any more questions, send me a message in Canvas. Otherwise,